Hello students, welcome to the fourth video of function. In today's video, we are going to solve some example based on types of function. So let us start. Example 1 says that if f of x is equal to 1 upon 1 minus x, then find f of fx. Okay, this is the example of composite type of function. So we have to find f of x. So now we know that f of x is 1 upon 1 minus x. Okay, so f of x means in place of x I have to write f of x. Okay, so in this equation x can be written as f of x. So f of x will be 1 upon 1 minus f of x. But we know that f of x is 1 upon 1 minus x, and that's why we substitute f of x value, and f of x value is 1 upon 1 minus x. Okay, so after substitution what I am getting, 1 upon this step 1 upon 1 minus x. Okay, now what I have to do, I have to cross multiply in denominator. So 1 into 1 minus x will be 1 minus x, minus 1 into 1 is 1 upon 1, right? 1 into 1 minus x, so 1 minus x. Okay, so 1 upon this term. Now I will take this denominator term in numerator, so that will be 1 upon 1 minus x upon 1 minus x minus 1. Now 1 minus 1 will be 0. So finally what I am getting? I am getting 1 minus x upon minus x. Now I am going to take this minus sign in numerator. So that will be minus 1 minus x upon x. Okay. After multiplying bracket with minus, I will get x minus 1 upon x. Okay. So f of x is x minus 1 upon x. Clear? So to solve this, what I have to do, I have to replace the x by f of x. Then I have to substitute the f of x value, which is 1 upon 1 minus x. Then I have to solve the terms. Okay. Now let us see the next example. Second example is based on odd and even function. See here, question is, state whether the function f of x is equal to ax plus a raised to minus x upon 2 is even or odd. Okay, now to check whether the given function is odd or even, what I have to do, I have to replace x by minus x. So f of minus x will be, replace x by minus x. So a raised to minus x plus a raised to minus x upon 2. So that is equal to a raised to x plus a raised to minus x upon 2, right? Which is nothing but f of x. Now replacing x by minus x, I am getting the same term, right? I am getting f of x only, and that's why the function is a even function. If there is no effect of minus sign, then that function is a even function. So what I am getting? I am getting f of minus x as f of x only, and hence given function is a even function. Okay. Now next, see third example. In third example, question is, if f of x is x cube minus 5x into cos x plus x square into sin x, then show that f of x plus f of minus x equal to 0. Okay. Now class, f of x is given as x cube minus 5x into cos x plus x square into sin x. What I have to show? I have to show that f of x plus f of minus x is 0. F of x is already given. So what I have to find? I have to find f of minus x. So f of minus x means I have to replace x by minus x. in f of x term, right? So here I am replacing x by minus x. So what I will get? Minus x cube minus 5 into minus x into cos minus x plus minus x square into sine minus x. Okay. So in this part, cos minus x is cos x, sine minus x is minus sine x. Okay. Then even power of x are positive, means if x raised to even number is given, then answer will be positive, and if x raised to odd number is given, then answer will be negative. Odd power of x are negative. Okay. So by using all this 4 part, we get, let me clear the screen, minus x cube. X raised to odd number is there, right? So answer will be in negative. So minus x cube minus 5. Then minus x. Minus 5 into minus x is 5x. Then cos minus x. Cos minus x is cos x. So 5x into cos x. Now x minus x square, even number. So it will be a positive number, so x square. But sine minus x is minus sine x. So x square into minus sine x. So that will give you minus x square sine x. Okay. So what I have done, f of x is given. Then by replacing x by minus x, I got f of minus x. Okay. After getting f of x and f of x, next I have to do the addition. So equation 1 plus equation 2 means f of x plus f of minus x. So f of x is x cube minus 5x cos x plus x square sin x, plus f of minus x is minus x cube plus 5x cos x minus x square sin x. Now x cube minus x cube 0, minus 5x cos x plus 5x cos x 0, x square sin x minus x square sin x 0. Okay. So finally what I am getting? I am getting f of x plus f of minus x equal to 0, and hence proved. Okay. Then next type, example 4, is again an example of composite function. Here two functions are given, f of x and g of x. And what I have to show that? I have to show that f dot g of x is equal to x. Okay. So let us start. F of x is given as 3x plus 4 upon 5x minus 7. And g of x is given as 7x plus 4 upon 5x minus 3. What I have to find? I have to find f dot g x. That means f into gx. Okay. Function of gx. Now, as we know that if f of x is equal to x square, then f of 2 will be 2 square. Right. This is the concept. What I am doing? I am replacing x by 2. Okay. In left hand side, also in right hand side. So same rule. F of x is given as 3x plus 4 upon 5x minus 7. Now I need to find f g of x. Okay. Now f g of x means in place of x, what I have to write? I have to write gx. So that will be 3gx plus 4. Okay. 3gx plus 4 upon 5gx minus 7. Okay. This is the concept. F of x is 3x plus 4 upon 5x minus 7. So f of g of x will be 3g of x plus 4 upon 5g of x minus 7. In place of x, what I have to write? I have to write g of x. Okay. So after writing this g of x, next step is substitute the value for g of x. G of x is 7x plus 4 upon 5x minus 3. Right? So in numerator, in denominator, in both the places, I am substituting g of x value. After substitution, next what I have to do? I have to multiply this numerator, means 7x plus 4 by 3. So that will be 21x plus 12, 21x plus 12 upon denominator will be as it is 5x minus 3 plus 4 upon, in denominator I have to multiply this 7x plus 4 by 5. So that will be 35x plus 20 upon 5x minus 3 minus 7. Okay, I will get this step. Now next step is cross multiplication. In numerator and denominator, in both the places, what I have to do? I have to cross multiply the terms. Now do the cross multiplication. So just wait, let me clear this side. Okay. Now when I do multiplication in numerator, then 21x plus 12 into 1, so that will be 21x plus 12, okay, plus 4 into 5x minus 3, right, and in denominator it will be 5x minus 3. This denominator will be common. Okay, this part is only solution of numerator. Then denominator will be this part, 35x plus 20, 35x into 1 minus 7 into, now again I have to clear the screen, so just give me a second, I have to clear this part. Okay, so minus 7 into 5x minus 3. Okay, then that will be incomplete because there is also a denominator term. Denominator will be 5x minus 3. Okay, now 5x minus 3, 5x minus 3 cancel. So finally what I am getting? I am getting 21x, this part, right, plus 12, then plus 4 into 5x, so plus 20x, then plus 4 into minus 3, minus 12 upon denominator is 35x, then plus 20, then minus 7 into 5x, so minus 35x, minus minus plus 7 into 3, 21, right? So now let me clear this part so you can easily see the terms. Okay, so now you can see this, I got this step, right? I got 21x plus 12 plus 20x minus 12 upon denominator is 35x plus 20 minus 35x plus 21. Okay, so in numerator plus 12 minus 12 will be 0. In denominator 35x minus 35x will be 0. So numerator is 41x upon 41. So 41 cancel. So that is equal to x. Okay. Then see one more example. In this example, what is given? State whether the function f of x is equal to e raised to x plus e raised to minus x upon 2 is odd or even. So again, this belongs to odd and even type. I have to check whether the given function is odd or even. So for that what I have to do, I have to replace x by minus x. So f of minus x means e raised to minus x plus e raised to minus x upon 2. So that is equal to e raised to minus x plus e raised to x upon 2, and that is nothing but the f of x. Okay. So again what I am getting f of minus x as f of x only, and hence the given function is a even function. Okay. So class, these are the examples of types of function. So with this I am concluding this video. So thank you students.